Good day folks. So I've been thinking of ways to improve my production quality, specifically video. Now at the moment I'm just using the built-in webcam of the laptop. Now that works pretty well because there's no additional setup and things just work out of the box. However, between my different laptops there are some very notable differences in video quality. So as you can see, this particular webcam, the image is pretty grainy and appear dark. So the low light performance is terrible. Now an easy way we can improve this is just to turn on some additional light. Let's do that. Ooh, okay, so that's not much of an improvement. I guess I'll need an external camera. Ah, I know. I've got an old DSLR that I can give a go. Ah, there we go. So step one, let's connect a power supply to this camera. Okay, step two, let's connect the USB cable to the camera. Okay, step three, let's plug in the USB cable into my laptop. Now we can remove the lens cap of the camera. And then we can turn on the camera and you can just listen to that DSLR startup sequence. There we go. Anyway, now let's just find this in OBS and then we can try it out. Huh. That's disappointing. Okay, so it turns out there's quite a few things one need to do to use an old DSLR camera as a webcam. So I found this Gphoto project, which is a remote control for cameras connected to a Linux host. Now they've got a list of supported cameras, so one do need to make sure that the specific model of DSLR is listed in the list of supported cameras. So the general idea, one would need to install the video loopback kernel modules for your distribution. Then one need to load the video loopback kernel module, and I understand this exclusive caps equals 1 is a very important option for this to work. And once the video loopback module is loaded, one will see that it creates a video device in the devices folder. One can then use the Gphoto command line utility to start streaming video from the camera, and one can use FFmpeg to encode that video and write it out to the loopback device. So once this is done, one can use this loopback device inside an application such as OBS to start capturing video from that camera. So what I'm going to do off camera is I'm going to follow the installation steps for Arch Linux, and then I'll talk you through setting up that video stream from the camera. Okay, let's quickly look at the steps necessary to load the kernel module. So first of all, if we already have the module loaded, we can just unload it with modprobe-r. So if we look at our video devices on this machine, we can see that we've got video 1 to 4, and I want the loopback device to be on video 0. So to load the kernel module, we can again run modprobe. So this time I've got exclusive caps equals 1, which we got from the Gphoto documentation. I've added max buffer equals 2 because I just want simple double buffering. And then I've added this video number because I want it to be on video device 0. So if we run that and we again look at the video devices, we can see that we've got video 0, which should be the loopback device, and we can use the Video for Linux command line utilities to verify if that's a loopback device. So Video for Linux control this devices, and as we can see there, we've got the loopback device on video 0. Now we want this to set up automatically every time we reboot the host. So there's a couple of files we need to create inside our etc folder. So first of all, inside the modprobe directory, we will have a DSLR webcam.conf file where I create an alias where I say DSLR webcam is the video loopback module, and then I supply the modprobe options that we used in the command line. Now the second thing here is we need to tell systemd to load this module every time it starts up. So for this we're going to create an etc module load DSLR webcam.conf file where we just tell systemd to load that module. Okay, so now if we restart the system, everything should be set up correctly. Okay, we can now look at using Gphoto as a remote control for the camera. So if we run Gphoto with the auto detect command line argument, it will list all the supported cameras connected to this Linux host. We can then copy and paste that command from the Gphoto website, where we pipe the output of Gphoto into FFmpeg. FFmpeg would then encode the video and write the output to the loopback device. Just very important, make sure that we're using the path for the loopback device. So we're going to start this. Okay, let's get that image up on OBS. Okay, so you should now be able to see two of me. Now you may notice that there is a slight delay between the two images. So I do find the command from the Gphoto website to be quite a useful starting point, but one do need to go through some performance tuning to find the arguments that's optimized for your specific laptop. Anyway, I'm going to do a couple of latency tests, and then I'll check back with you in a bit. Okay, this is a latency test using the default arguments from the Gphoto website. Test in 3, 2, 1. Okay, latency test using FFmpeg arguments that's been performance tuned for this particular machine. Latency test in 3, 2, 1. Okay, so that slight delay between the sound and when events can be seen on the video is a bit annoying. Now, with some performance tuning, it does improve. However, I wanted to see how it compares to an HDMI capture device. So I've ordered the cheapest HDMI capture device that I could find on Amazon. So this is a Ugreen. And I found an HDMI cable for my camera. So just for comparison, I'm going to repeat the latency test, but this time using the HDMI capture device. Okay, this is a latency test using the Ugreen HDMI capture USB device. Latency test in 3, 2, 1. Okay, so I'm personally a bit underwhelmed by the HDMI capture device. So first of all, it feels like the video quality has taken a step back. And second of all, that HDMI capture device still have the same problem with there being a noticeable delay between the sound and when events happen on the video. Now, maybe if I spend some money and invested in a high-end device, those problems with the latency and the video quality would significantly improve. However, this channel is just a hobby and I'm trying to get by on a shoestring budget using my existing hardware. So my final verdict, it's a bit annoying to have that delay in the process, but with some performance tuning that latency becomes more passable. Anyway, I'm quite pleased with the improvement in the video quality, and I can now do that thing that DSLRs are famous for, bokeh. Anyway, I should be back with some more programming content in my next video. If you like this video, click on the like button. If you want to see more, subscribe, and I will see you next time. See ya.